To understand the making of our planet, we need to fast forward through millions of years. A hail of meteors. $3.9 billion years ago, and we're under attack from debris left over from the solar system's formation. Look at these strange crystals inside the meteors. They look like grains of salt. The same salt you'd put on your French fries. And inside these, minute droplets of water. It seems these deadly missiles could contain the vital ingredient for life on Earth. There's only a small amount of water inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The water collects on solid ground. The Earth's core remains molten, but its surface has cooled to around 70 or 80 degrees, just enough to form a crust. In the future, we could swallow this water when we take a drink. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of kilometers to reach us, carried inside a meteor. The Earth looks more familiar, but this is still a dangerous place. This wind is as fast, perhaps faster than the most destructive hurricane. It's a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth that its gravity is overwhelming. It creates huge tides that race across the planet's surface. But over time, the moon moves away. The waves calm, and the planet spins slower. $700 million years after the planet's birth, life-giving water covers its surface. But not just water. There's something else down there. Tiny islands. They seem to have appeared from nowhere. Until molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools and forms a volcanic island. This is how these islands formed. In the future, they will join together to form the first continents. The infant Earth has water and land. It's beginning to look like the planet we call home. But the atmosphere is toxic, and the temperature is scorching. Nothing could live here. Meteors. They've been raining down since the planet's formation. But now, 3.8 billion years ago, the assault has entered a violent new phase. Something has disturbed the orbits of these meteorites. They already brought water to the planet, but they're carrying something else too. As the meteorites dissolve, they release their minerals and transport carbon and primitive proteins, amino acids, from outer space to the bottom of the ocean. It's dark. The sun's rays can't reach beyond 300 meters, and it's close to freezing. This must be a mirage. A city of underwater chimneys. It's not smoke. It's some kind of hot liquid. Seawater has seeped down into the earth through cracks in the crust, getting hotter, collecting minerals and gases on the way. It's this potent mixture that's spewing back out into the ocean, building these towers. Add to this all those minerals and chemicals from the meteorites, and the water has become a chemical soup. It's impossible to know how or when, but somehow these chemicals have come together to create life. The water is now full of microscopic organisms. These single-celled bacteria are the earliest forms of life on Earth. This is a defining moment in the making of the planet. Microscopic life is underway. To find more complex life, we need to travel forwards through time to 3.5 billion years ago and a shallow ocean. These look like rocks, or even plants. They seem to grow out of the seabed. Each is a mountain of living bacteria, a colony called a stromatolite. As if by magic, these bacteria turn sunlight into food. This process, called photosynthesis, uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar, and similar to the stuff we put in our coffee. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the single most important element for life on Earth. Without them, virtually every living thing wouldn't exist. When we take our next breath, we're doing it thanks to these colonies of ancient bacteria. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer. Now they last at least 16 hours. We're discovering it takes a long time to make a planet.